can now move to our Purlin. We'll come back. Now we now move to the next item, which is the Purlin. And that is 50. That is 75. Okay. So now we have to calculate the Purlin for this place and this place. We can now multiply by 2. So the first one is okay. Let's consider this. So what is our length here and here? Don't forget this is 30.2. Considering is that what we have? Okay, is 25.2. Considering the eaves projection. Why? What do we have here now? What's our hypotenuse here? Remember, we earlier on we did this. It was 3 taking post. This 6. Then eaves projection 0.6. So what do we got? What do we get? Yeah. How was the figure we got when we were trying to do the rafter? The rafter.
7
6.7.
It means if you 36 plus 9, square root of 36 plus 9.
Yes.
Yeah, that should be root 45. That's 6.7.
6.7, yes. Plus 0.6, 7.3. Actually, 7.3. Now, we need to add the projection, the sheet projection. Say the last Purlin. Okay, we want to calculate the Purlin. Yes. So this is 7.3 meters. 7.3 meters. So now, we need to determine the distance. We are using log span. Log span. Note of that, log span. So we are using log span. We are using 0.55. 0.55 mm gauge. So, in this case, we can space it up to 0.9. I wouldn't want us to go for 0.9. Let's consider 0.8. 0.8 would be about how many inches? That's 31.5 inches. 31.5. Or should we go for 0.76 and 30? 0.76. Let's go for 0.76. So, number of Purlins required now. And how many in this way do we need? That will be 7.3 divided by 0.76. Since the spacing, we are using 0.76 center to center. So what will this give us? I want to know how many rows are we going to have this way. We have now calculated
10.43.
10.4. So which means it's 11 rows that will be there. The only thing is that the last one will not be up to this width. It will be small. So it means we are going to have 11 rows. 11 rows. So yeah, now after that, okay, we can also, to make it, we have discretion to be used. You can decide to cut this more to have a kind of okay, let's see what the tool will give us. Do not forget this place is 3.6. 3.6 plus 0.6 in this case now. 6.6 plus 0.6, that's 4.2. So here also will be 4.2. 4.2. Here too will be 4.2. 4.2. So you can now say 4.1 plus 4.2, that's 8.4. 25.2 minus 8.4. 16.8 meters. So this rectangle is 7.3 by 60.8 meters. While this right triangle is has 7.3 height, 4.2 base. So we have two options to go now. The first one is to calculate this one separately, the rectangle separately. Then we'll do this triangle separately. The second option is to calculate it together, just deducting a certain percentage from this. You can ideally suppose to say from here to here, yes, from this place to this place, because this will cover up for here. Yes, that can also guide us. Can also yes, it is workable. Can be that way. But in that case, that will now be 25.2 minus 4.2. So from here to here, the dimension from here to here, so which will be 21 meters. So let's use this 21 meters. Divided by the length of the purlin now. Now we need to determine our purlin, is it going to terminate, are they going to terminate on rafters, or they are going to, wherever they meet, they will now put a pattern. We need to decide how will guide us in what we are doing. We need to decide how will guide us in what we are doing now. So if it will end on each of the rafters, it means the length we are going to use has to be 2.4. Cannot use 3.2, and our length is not 3.6. So it means one length of wood will only cover 2.4 meters. So there will be off cuts of about 0.8 meters or 0.7 meters. There will be off cuts like that. So there will be much off cuts in that case. It would have been better if that is what we will get to use. It would have been better if we consider 1 meter spacing of the rafters, so that that will be 3. When it's cover 4 after, that will be 3 meters. So we have 2 off cuts. So now, so what should we do now?
Let's consider 1 meter. 1 meter spacing.
No, we are not talking of the space. The rafter, the purlin that is going to stay.
The purlin where it meets on rafter that
you cannot go back to the rafter.
Okay.
You cannot go back to the rafter.
They will lap it anywhere
It says so we do not have consider the lap joint, the lap parting joint. So now you can now divide this by say 3 meter. Okay, so 3.2. 21 divided by 3.2 will give us what?
21 divided by 3.2.
Yes.
That's 6.56.
6.5.
6.56.
Okay, you can say. So it means we need 6 length and 0.6. 0.6. Okay. Say 6.6 length So this is approximately 7. So the joint actually will be 6. Joint will be 6. If you have 2 wood now, how many joints I can only have there is 1. If there are 3, the joint will be 2. And so the joint will be, so the each joint, what are we using for each joint, for each of the joints? How many, what's the lap length? Or the joint length, that we want to consider. For thread, okay, let's say 500. So 500, and we need it in 6 places. That's 6 and 500 times 6, that's 3 meters. So that is 500 times 6, that's 3 meters. It is about the one length. One length. One length is 3.2. So you can now say this one plus the 6.6. This should be approximately to be 7. That will give us what? 8 numbers. It means this one like this, from here to here, averagely, it will be 8 numbers of wood. Now, and we have how many rows? 11. We have 11 rows covered. So that will now be 11 times 8. That is what gives us 88 numbers. That's for one side. For one side. So this is the first this thing that I wanted us to use. Then you can also consider it this way. You can do this separately. I'll now do this one. You can multiply whatever I get the times 2, then add it up with this one. And even this that we got, because there will be off cuts here, there will be off cuts. We need to add something to it. There will be off cuts because this and this, you just have to bring it together. So there will be off cuts. So which you have to consider. Let's say 2. So let's approximate this to 90 numbers. Okay, I think we can go on with this. So now times 2 the other side. So times 2, 90 times 2. That gives us 180 numbers. It means we need 180. Let's write it out. 180. Now we need to consider the triangles. Sides that are triangle. Triangle side. This will be what? 12 plus the eaves projection now. 13.2. 13.2. This is what? As we go back to our calculus, this is 3 meters. This is 3.6. What do we have there? We have 0.6. That's 4.7. 4.7 plus it at 5.3. So it means here will be 5.3. And this is the number of rows that we need. Number of rows. Even here, number of rows there have to be 12 plus 1. It has to be plus 1. It has to be plus 1. 12. So this should be 12. 12 times 8 is 96. 96. 96. Yes. 96. So 96 times 2. numbers, you can say 100 and 200 was making into 200. Now consider all of cut and the irregularities. So then now 5.3 divided by 0.76 give us what?
6.97. I just use 7.
Just 7 numbers. So 7 rows. Rather, let's have 7 rows this way. This one of the rows. Yes. Now, I have known that we need 7 plus 1, 8. I want to repeat the mistake. 8. Now, what else do we have to consider here? Okay, now, what will now be the length of each of these? What will be the length of each of the rows? So we have the option to calculate the to do this, to consider this and use it all through, half of it all through. You don't actually need this here. This is not useful here. This is 13.2 divided by 2. 6.6 meters. So you can say 6.6 meters divided by the length of each one is 3 point. You use 3 or 3.2. 3.2. Oh, that is 2.06. 2.06.
2.1
look, we have 2.0. Okay, 2.1. 2.1. Okay. Let's approximate to 2.5, but there will be 2.1. Approximate 2.5 numbers. So there will be off cut, not off cut in this case. So you now need 2.5, 2.5 numbers times number of rows 8. That will give us what?
What?
2.5 times 8, 20. That's for this side. Then times 2, the other side. That's 40 numbers. I think you have considered it. Okay, it remains the joints. The joints. Do we add the joints here? I think we added it somewhere where we want that. I wrote it somewhere here. Try and put line like this. We are going to have 7. Okay, which now turns to 8. The joint should be there. Now added it. Okay, yeah. This is joint. This is enough.
Okay,
Yes.
500.
Yes. So if this is taken into account, this time is each of them will be 2. There will be 2. There will be 2 joints and 1. So that's 2. That 2 times 8. That's 16. 16 times 2. Or say 16 times 0.5. That will give us what?
16 times 0.5.
Yes.
That's 8.
That will be 8. 0.2, that's 8 times 2. Okay, no, yeah, that's 8 meters. So now the 8 meters now divided by the length of the wood 3.2. That gives us what? 8 divided by 3.5 times 2. That's 5 numbers. Why do we get this 134? Okay, this is where we started our polling from. So we have 200 and 40 and 5. What else we need to consider as far as the polling is concerned? Polling. You don't have any other thing to be considered fully. Everything is fully considered. So all our answer be 200 plus 40 plus 5. That's what 245. I think we don't need to add more or do we need to add anything more? No. So we can go straight and input it. So that will be 50 by 75 and then into 45. Can just add 5 here because I have, let's make it 250. There might be discount and the likes. And I've been mistaken for why 40. Okay, let's even do. You add 5% to this. It's not still bad. It's not a bad idea. Let's be more realistic. 5%
That's
consideration.
257.25.
257. Okay. 5% consideration. All consideration. So 245 times 1.05 equals 258. So 258 times all the price of our Purlin 2 by 3.
500.
2 by 3? No.
8. Some people give us 750, some people 800. But you gave 850 or so. Let me check.
Okay. This is 800. So 800. So 258 times 800 is what?
206,400.
258 times 800.
Yeah.
206,000.
Okay, 2 by 3, you gave us 700.
Please just use 700 then. Rico.
But someone else gave us how much? 2 by 3.
108,000.
180,000.
600.
2 by 3. Another person gave us 750.
So,
Another person 700. Between 700 750.
okay. So now, we can now move to our facial board. I'll now move to our facial board. I'll just hand it up to this. We can't do nothing now, up to this treatment.
Don't forget, which, okay, it's 2 by 3 we use to do all Odds range. Odds range.
That's why we have to be the scaffolding a bit.
Yeah.
So we have
Ladder.
and so that's the reason for all those at 5% tracks that we added. So we can't really have enough. We add too much now, for instance. So after the end of the thing, so it will be waste. All the material will be waste. So as they are moving on, they'll be dismantling some. We will using them. So at the end of the day, we have too much waste on ground. I want to resell them. Remember, you can't sell it at the rate you purchase them. Can we go for the next one is the fascia. That's number 7. Fascia board. So our fascia, that is simple. Our fascia, we can don't let us do 9 gaps. So that will be because we do gaps, they don't give us the accurate. We have to add more. So let's consider this is 13 points. Okay, 25 point. The length is 25.2 divided by the length of the board is 3.2. What will this give us?
25.2 divided by 3.2.
Yes.
7.875.
As 8 boards. Okay, 7.88. 7.8. We need 2 times 2 for the other side. That's 16 numbers. Now the breadth 13.2 divided by 3.2.
13.2 divided by 3.2. 4.125. So we need 4.13. So approximately 4.5 times 2. That gives us 9 numbers. 9 plus 16, that's 25. No waste, no additional. So what's the price of our fascia? Which is 25 by 250. As what? 25 times 3, 4,200. That will give us what? 105,000.
25 times 4,200. It has to be 4 inches nails and 3 as well. So majorly 4. Now in this case, though I'm not done our noggin, we have to, the noggin has to be considered first before the nail, so that you can have the nail for the noggin as well. 3 inches nail. The noggin, okay, since actually noggin has to be done room by room. It has to be done room by room. But because okay, if you don't do it that way, you can actually get the right quantity of noggin. And as you can see, this is the plan. So I have to do this separately. Each of the rows separately. So the apartment is a 3 bedroom, is a 2 flat set of 3 bedroom. By the time we do for one side, we just multiply it by 2 for the other side. Just multiply it by 2 for the other side.
The wrong direction.
Yes.